Today, we have an incredible story about the first interstellar object ever discovered in our solar system, Oumuamua. This mysterious object, whose name means scout or messenger in Hawaiian, has puzzled scientists since its discovery in 2017. But thanks to the diligent work of two astrophysicists from Arizona State University, we now have a better understanding of its origin. In 2017, astronomers using the Pan-STARRS Observatory in Hawaii made a groundbreaking discovery, an object from beyond our solar system passing through. Named Oumuamua, this object exhibited some comet-like features, but also had several characteristics that defied easy classification. Two astrophysicists, Stephen Desch and Alan Jackson from ASU's School of Earth and Space Exploration, decided to take on the challenge of explaining Oumuamua's peculiar features. Their findings, recently published in the AGU Journal of Geophysical Research, Planets, suggest that Oumuamua is likely a piece of a Pluto-like planet from another solar system. Desch explains, in many ways, Oumuamua resembled a comet, but it was peculiar enough in several ways that mystery surrounded its nature, and speculation ran rampant about what it was. From their observations, Desch and Jackson identified several key characteristics that set Oumuamua apart from typical comets. Firstly, its speed upon entering the solar system was slightly lower than expected, suggesting it hadn't been traveling in interstellar space for more than 1 billion years. Secondly, its shape was more flattened, resembling a pancake, unlike any other known object in our solar system. One of the most intriguing aspects was Oumuamua's slight push away from the sun, a phenomenon known as the rocket effect, which was stronger than could be explained by traditional cometary models. Additionally, it lacked a detectable tail, a common feature of comets due to escaping gas. To understand these anomalies, Desch and Jackson hypothesized that Oumuamua was composed of different types of ices and calculated how these ices would behave as they sublimated or transitioned from solid to gas when the object passed by the sun. That was an exciting moment for us, Desch recalled. We realized that a chunk of ice would be much more reflective than people were assuming, which meant it could be smaller. The same rocket effect would then give Oumuamua a bigger push, bigger than comets usually experience. Their calculations pointed to one specific type of ice, solid nitrogen, that matched all the observed features of Oumuamua. Solid nitrogen ice can be found on the surface of Pluto, suggesting that Oumuamua might be a fragment from a Pluto-like planet. Jackson explained, "We knew we had hit on the right idea when we completed the calculation for what albedo, or reflectivity, would make the motion of Oumuamua match the observations. That value came out as being the same as we observe on the surface of Pluto or Triton, bodies covered in nitrogen ice. Further calculations showed that chunks of solid nitrogen ice could have been knocked off the surfaces of Pluto and similar bodies early in the history of our solar system. These fragments could then travel through space and eventually reach our solar system. It was likely knocked off the surface by an impact about 500 million years ago and thrown out of its parent system," Jackson said. Being made of frozen nitrogen also explains the unusual shape of Oumuamua. As the outer layers of nitrogen ice evaporated, the shape of the body would have become progressively more flattened, just like a bar of soap does, as the outer layers get rubbed off through use. Despite Oumuamua's comet-like nature being quickly recognized, the inability to explain it in detail led to wild speculation, including the idea that it might be alien technology. This speculation was fueled by Harvard University's Avi Loeb in his book, Extraterrestrial: The First Signs of Intelligent Life Beyond Earth. Desch emphasized the importance of rigorous scientific investigation, saying, "Everybody is interested in aliens, and it was inevitable that this first object outside the solar system would make people think of aliens. But it's important in science not to jump to conclusions. It took 2 or 3 years to figure out a natural explanation, a chunk of nitrogen ice, that matches everything we know about Oumuamua. That's not that long in science, and far too soon to say we had exhausted all natural explanations. As a fragment of a Pluto-like planet, Oumuamua offers a unique opportunity to study extrasolar systems in a way we haven't been able to before. Discovering more objects like Oumuamua will help scientists better understand other planetary systems and how they compare to our own." Desch remarked, "This research is exciting because we probably resolved the mystery of what Oumuamua is and can reasonably identify it as a chunk of an exopluto, a Pluto-like planet in another solar system. Until now, we've had no way to know if other solar systems have Pluto-like planets, but now we have seen a chunk of one pass by Earth." Looking forward, Desch and Jackson hope that future telescopes, like those at the Vera Rubin Observatory in Chile, will enable the discovery of more interstellar objects. These observations could provide valuable statistics on the types of objects passing through our solar system and further test their hypotheses. Jackson added, "It's hoped that in a decade or so we can acquire statistics on what sorts of objects pass through the solar system, and if nitrogen ice chunks are rare or as common as we've calculated. Either way, we should be able to to learn a lot about other solar systems and whether they underwent the same sorts of collisional histories that ours did. The story of Oumuamua is a fascinating one, as it represents our first glimpse of an object from beyond our solar system. Its unique features and the journey it has taken provide us with valuable insights into the processes and events that shape planetary systems. The work of Desch and Jackson highlights the importance of careful observation, rigorous scientific analysis, and the willingness to question assumptions. As we continue to explore the cosmos, discoveries like Oumuamua remind us of the vastness and complexity of the universe. They challenge us to expand our understanding and inspire us to keep looking beyond the familiar. Thank you for joining us on this fascinating journey into the origins of Oumuamua. If you found this video informative, please like and subscribe to our channel. Don't forget to hit the notification bell so you never miss an update on our latest discoveries. See you in the next video.